Welcome to video number 23. We're going to be talking about free body diagrams and components of a free body diagram. So basically we're going to start off really simple again. Here you can see there is gravity pushing it down, or the box pushing down to, and then there is the actual surface pushing back at the box, which is the normal force. So we have the normal force and then we have mg. But let's say that there is a force moving the box, pushing it right here, meaning there's a force here pushing that way. Now if we were to, let's say, introduce friction, friction would be pushing in the opposite direction that the force is being applied to, or it would be pushing it would be pushing parallel to the ground, and the sign there is friction. So yeah, however, what if a box has a force that is what if a force is being exerted on a box that is not parallel to the ground? Let's say upwards like that. It still has both of the components mg and normal force, except for if we break it up into components, we have force sine theta and force cosine theta. So basically we have n plus force cosine theta up here, and then here we have f sine theta. So now let's look at a problem. So number 23 gives us a sketch already of a free body diagram. Here's the box. In the diagram, you can see that the arrow pointing upwards is much larger than either of the arrows. So if it doesn't look like that, that's just an error on my part. So we're going to start by labeling the components that we know are there. For example, mg, and we know that there's also an equal force of n. However, we see that n seems to be a lot greater. So that means there must be another component that is added to n. And we saw that earlier, a force that is exerted at a certain degree to a box in an upwards direction must be broken up into components. So here we could see this is probably n plus f cosine of theta, while this is something like f sine of theta. So now we know that if we took away if we brought the components back together into the original way that the force was applied to, the force would be applied to something like this. So we know, therefore, from the options that A is the right answer. Ooh.